Thank you for that. I appreciate it. And Brooks, thanks for inviting me to come today. Super excited to talk to you. It's really an exciting time in the artificial intelligence space. Just came from New York earlier this week, speaking at a couple AI conferences up there, and it's just incredible to see all the interest that's going on in the space. So I'm going to try to give you some practical information that will hopefully kind of ground you a little bit in what's going on in practice. There's a lot of stuff that you hear about in the tech press and other locations. Some of that is outstripping actually what's going on in the real world. And I have a good understanding of both the research and what we're seeing in the business space. We already kind of talked a little bit about my background. I've run a couple of AI companies now. My current company is a spin out of Duke. Our chief scientist is the vice provost of research at Duke. We're a machine learning services company helping large companies determine how to deploy machine learning, how to create a strategy around artificial intelligence, and ultimately how to make the best use of the technology in their environments. We have a team of experienced machine learning engineers, a number of PhDs, and again, we're at the forefront of research when it comes to machine learning. So Infinia, we're all about making business impact. One of the things that's great about Dr. Karen, our chief scientist, is he's an academic, but he also loves to see applications of the technology in the real world. And so we really think about business applications in three ways. One is reducing cost, two, increasing efficiency, or three, achieving breakthroughs. And the great thing about machine learning, which I'll get into a little bit later on, is I think we're at a point now where the capability is such that we could stop innovating around machine learning. That is no new research, no new papers, and there still would be a 10-year backlog of deploying machine learning inside of the enterprise. And by the way, the research isn't stopping. Innovation is going at a crazy rate, and so I only see that backlog growing over time. The main reason is a lack of understanding about machine learning and the skill sets necessary to implement it. All right, so I'm going to talk to you a little bit about artificial intelligence. I think it's good to kind of level set what I mean by that. You ask 10 people, what does artificial intelligence mean? You'll get 10 different answers. My definition is pretty mundane. I actually view it as a field of computer science that's composed of a variety of branches that include things like machine learning, natural language processing, computer vision, robotics, et cetera. And within that, machine learning, which is again an area that's had the bulk of the advances that you hear about, some of the cool things that are going on are a result of machine learning. Within machine learning, there's a variety of techniques and attributes that you probably heard about, things like supervised learning, unsupervised learning, transfer learning. There's a new form of learning that seems to come out every week. So again, these are, it's hard for even someone like me that is, trying to stay up to date with the latest and greatest to stay up to date. So folks that aren't living and breathing this every day, it's near to impossible given the rate of innovation. The interesting thing about defining artificial intelligence as well is that it's a moving target. I have a friend that describes it as what computers will be able to do in the future that they can't do right now. Because things like speech recognition, which was largely an unsolved problem 10 years ago, or at least we weren't very good at it, is now largely a solved problem. But yet you don't walk around and point at things like Siri and say, wow, look at that cool artificial intelligence in my pocket, right? Now we just take it for granted and we assume that it's a part of everyday technology, when actually there's a lot of interesting artificial intelligence going on behind the scenes. So if I had to describe what does machine learning mean, so let's pick that apart a little bit. I like to actually use this example, which was the definition that the person that coined the term back in 1959 gave, which was giving the computers the ability to learn without being explicitly programmed. Now the key thing about this isn't even really the definition as much as it is the year, 1959. That's when machine learning was originally coined. It's taken a long time to get to the point where we're at now, where actually you can see a lot of interesting applications of machine learning. I'm going to show you just a few charts that kind of put this into context. This is the Gartner hype cycle. Many of you have probably heard of the hype cycle. Machine learning is at the peak of inflated expectations. And so that means, it is actually about as hyped as any other technology can be at this point in time. That said, I do expect there to be a pullback over the next few years. We can only take so much hype around a technology before people start to get skeptical, maybe before you hear about some projects that were significant failures. That'll start to happen and start to creep in. It'll actually be a good thing for machine learning because the expectations have outstripped exactly what can be done with it currently in the industry. And so it'll help level set expectations, hopefully level set wages as it relates to machine learning engineers. Something I wrote about quite a bit is something I refer to as the technology innovation potential of particular types of technology. I won't get into all the detail here, but what I will say is that the innovation potential, that is the potential of good things that can be created with something, is extremely high with artificial intelligence. And that's primarily because there's a decentralized platform, that is things like TensorFlow and PyTorch and the core platforms that people are using to create machine learning and other forms of artificial intelligence is largely decentralized. That is, it can benefit from lots of people programming. And then the barrier for a developer to do something interesting with machine learning is also relatively low. This is the first time in a long time that we've had a technology that has both of those characteristics, and I think it really leads to a lot of interesting potential for the future. The last chart I'll show you is the technology maturity S-curve. So the first chart was the hype cycle. We're at the peak of the hype. The second one was the innovation potential. There's significant potential for this. The third one is, so where are we at in the maturity of the actual technology? It's actually relatively low. And specifically as it comes to productionalizing or deploying machine learning, we're in the very early stages. And so again, this is part of setting expectations. There's lots of hype, there's lots of potential, but we're still very early on, and it's going to take some time before we see maturity in that space. So I think about the four industrial revolutions. Steam, electricity, and computing were the first three. I do believe we're in the fourth industrial revolution now, which I would call intelligence. Again, these are subjective, there's not like a definition of what counts as an industrial revolution and when it begins and ends. But I do think we'll look back on roughly 2010, 2012 was really sort of the beginning of a lot of the innovation around, or that you're seeing come out of machine learning. But I believe we're in a new era of intelligence that's going to really lead the next many years. Many of these other ones lasted 100 years, 50 years at least. We're going to be talking about machine learning and artificial intelligence for the foreseeable future. So next I'm going to talk a little bit about some where I see things going. One thing to know is anytime you make a prediction, you're likely going to be wrong. So take these with a grain of salt. It's based on everything I've learned and assessed over the last several years as I've been working in the space. The good news, and I'll start with the good news, there's no path to artificial general intelligence, AGI, you may hear it referred to as that sometimes. Sentient beings, robots that can think on their own, despite what you hear about in the press, and I still see articles almost every week talking about somebody's working on something related to robots that can operate on their own. It's not there. The research there's no path to it in the research, there's no applications for it in the real world. We're not anywhere close to that happening. That's not to say it couldn't happen in some period of time, but at least as of right now, there's nothing to indicate that we're going to get that. And a good example of that is we're able to actually simulate about as many neurons as an ant has in terms of what we can produce artificially. And yet we don't have robots that can operate nearly as well as an ant today. And in fact, you may have seen some of the Boston Dynamics videos that have come out. They're probably some of the best robot makers in the world, and they produce robots like that, and you look at it and you're like, oh gosh, I need to pack it up and head out to the mountains and live out in the woods, I guess, because the robots are coming. But these are artificially created, essentially. The remote controlled robots. These aren't, somebody didn't go tell the robot, all right, go sit up on the platform, do a backflip and raise your hands, right? So it's not thinking to do that independently. We're getting good at some of the mobility characteristics of robots, but again, we're nowhere near having to worry about one of those coming and knocking on your door one day. Lastly, on this, there was a study that was done last year where, this is actually a research paper where several hundred researchers were asked, when do you expect certain things to occur? For example, the full automation of all labor, right? And I'll talk a little bit more about this shortly, where a lot of concern and a lot of discussion around what are we going to do about jobs? Robots are coming for our jobs. They're going to take all the jobs. Essentially where the researchers came out is it's at least 100 years out that we would be looking at something as technology being able to achieve something like that. And I have a hard time predicting 5 to 10 years out. Saying something that could be 100 years out is essentially like saying you don't know. So again, trying to give some comfort on that. Where the big advances have occurred is something called deep learning. And again, maybe you've heard about that. It's essentially an evolution of machine learning. The way to think about it is simple neural networks. Neural networks is a type of machine learning. On the left-hand side is the traditional simple neural network. You have an input, there's some calculations that are performed on that input, and then it produces an output. That only achieves sort of moderate gains when it comes to analysis. Over the last 10 years or so, a lot of progress has been made in deep learning, where you have an input, lots of intermediate layers, that's why they call it deep, and then an output. As computing and data has become more accessible, the types of things you can do with deep learning neural networks has grown significantly, and that's where a lot of the progress has been made. Just to walk through some of the examples that you may be familiar with, one is with image and video object detection. In computer science, they refer to this as computer vision. We've gotten really good at being able to detect faces, to detect and automatically determine that it's a cat in a picture and a dog in a picture. So in general, you're going to see, and you'll continue to see, lots of innovation around imaging in this space, right? When it comes to understanding and detecting what's going on inside of images. A couple of examples that my company, Infinia, is working on, automatically detecting objects within X-ray images so that you know what's in a suitcase, for example. And then the one on the right, which I'm sure all of you are familiar with, is the brachial plexus. That's our bounding box around the brachial plexus to identify it in an ultrasound device so that we can let doctors know what they're looking at. All right, the next area that's has seen significant advances is in natural language, and this is an area that I've spent a lot of time in. And again, it's much of the same story as what I was talking about with computer vision, where classical NLP, which is what I'm showing on the top, traditionally has been done through more brute force mechanisms, right? Where you've tried to fully specify language, and so you can break it down and hopefully model it in a way that makes sense. The problem, as you know, is language is not something that's easily specified. And so in general, natural language has always had kind of mediocre results when it comes to AI. Now, thanks to deep learning, we're seeing all sorts of amazing results, and that'll be an area that we'll continue to see lots of interesting progress over the next few years. One example, my first company, Automated Insights, which they mentioned earlier, is in the natural language generation space. And so they take data and turn it into content that sounds like a person wrote it. Again, it's quantitative analysis. This is examples where we produce earnings reports for the Associated Press, taking earnings data and automatically generating a report. Odds are that you've read automated content like this and didn't even know it, right? It's gotten that good. Other areas of natural language include natural language understanding, and so this is sort of the holy grail when it comes to natural language, where can you actually understand what somebody said in a sentence? It's very difficult, it's challenging, in part because it's ambiguous in many cases, what was meant or what was said. This is where there's a lot of work around chatbots and really trying to explore interactions between people and software, and can you fully essentially fake what a human interaction would look like. Another one is summarization. This has been sort of another canonical example in the natural language space, where you have a source document and you want to summarize it down to 1 or 2 sentences that essentially describes the essence of that story. Traditionally been very difficult. Now, through deep learning, there's something called abstractive summarization that allows you to summarize a document into something that actually may not even use the original words that were used in the source document. And these are getting really good. And then the last is question and answer. And again, that kind of gets back into the chatbot space. Lots of work in chatbots. You'll continue to see more and more chatbots, whether you like interacting with them or not. This is probably the go-to place where a lot of companies spend time, trying to explore artificial intelligence and integrating it into their processes. One, kind of myth I'll dispel is we will not be seeing full-length books generated from artificial intelligence. I keep hearing about this in the press, but the state of the art right now produces crap for the most part. You could train on all the Harry Potter novels and then try to produce a new work of Harry Potter, and it just comes out messed up. And in fact, this is the big challenge with natural language. This is the reason why I was the most interested in it. It's the hardest because you have to be able to maintain a thought throughout several sentences, maybe several paragraphs, and that's extremely difficult with the current state of technology. All right, so another thing that I'll mention, if I can. And again, this is sort of an optimistic viewpoint on this, but I do believe it to be true, because I get, I do lots of interviews related to the future of jobs. My last company, Automated Insights, I got interviewed a lot about what's the future for journalists. If we're automating content, does that mean that we're going to automate journalists out of a job? And the short of the answer is no. We actually we're not aware of ever, our implementation resulting in someone losing a job. And the key point is there's going to be a lot of jobs that will get automated, but they're the kind of jobs that should have never been done by a person in the first place. It's just we have people doing them today because there were no other options, right? We should not have a person staring at a screen for hours and hours trying to detect subtle differences in movement or detect things going on that screen. We should not have people that read and look at numbers, try to analyze it, and just strictly try to communicate the results of those numbers in written form. These are all things that we're used to people doing them, but that doesn't mean that we're making the best use of people's talents by having them do that. And so in the future, or in the near future, I would say, most of those kind of jobs that are getting automated that you'll read about, think about it in the lens of, should we have people doing those kind of jobs anyway, or is it better off to actually have those automated and likely find better places for people to do work? Again, another great slide when people like to challenge the notion that there's a lot of disruption going on in the workforce today. I would argue there is about at the same level as traditionally there's been disruption in the workforce, and just look at the unemployment rate, right? And this is the similar kind of rate that you're seeing in a lot of developed countries. We're at historic lows for the unemployment. And that's going to continue at least for the next few years likely. Again, it's hard to predict much beyond 10 years, but in the foreseeable future, we don't have a jobs problem. We have more of a skills problem, and that's what we need to solve. The last point I'll make is, again, you should feel safe to know that there's certain attributes of humans that are very difficult to automate. Creativity, being empathetic. These are things that are likely not going to be automated anytime soon. And again, the worry about are there going to be enough jobs for people, I think is largely misplaced. Also, we have people that seem like they need to constantly sell stuff, so I'll do that. We're working on a book called Machine Learning in Practice. It'll be due out next winter. We're publishing a lot of early drafts on machinelearninginpractice.com. I'm teaching a class at UNC in the fall. It's an upper-level MBA class, all about how you apply machine learning in the business world. Thanks.